Space travel began on October 4, 1957. Soviet countries Sputnik 1. After this, in July 1958, Sir Dwight D. Eisenhower signed the National Aeronautics and Space Act, which later became a business agency on October 1, 1958. This is my NASA. After this, a lot happened. Yuri Gagarin's Vostok 1 orbited the Earth in April 1961. Sir Neil Armstrong set foot on the moon, which was the first spacecraft for the first space mission to Mars. The Viking 1 spacecraft was the first to successfully land on Mars. The Viking 1 mission launched on August 20, 1975, and the lander separated from the orbiter to touch down on the surface of Mars on July 20, 1976. The Viking 1 mission was part of a two-part mission to study the Martian surface and atmosphere and search for signs of life. The Viking 1 mission included both an orbiter and a lander and was designed to take high resolution images of the planet. Before the Viking 1 mission, no one knew what the surface of Mars looked like up close. The first successful flyby of Mars was on 14 to 15 July 1965 by NASA's Mariner 4 on November 14, 1971. Mariner 9 became the first space probe to orbit another planet when it entered into orbit around Mars. The amount of data returned by probes increased substantially as technology improved. Viking 1 Mars Mission Jet Propulsion Laboratory, NASA Jet Propulsion Laboratory .government, HTTPS www.jpl.nasa.government. Missions Viking 1, the first spacecraft to successfully land on Mars. Viking 1 was part of a two-part mission to investigate the red planet and search for signs of life. About the mission, the first spacecraft to successfully land on Mars, Viking 1, was part of a two-part mission to investigate the red planet and search for signs of life. Viking 1 consisted of both an orbiter and a lander, designed to take high resolution images and study the Martian surface and atmosphere. Operating on Mars, Planitia for more than 6 years, Viking 1 performed the first Martian soil sample using its robotic arm and a special biological laboratory. While it found no traces of life, Viking 1 did help better characterize Mars as a cold planet with volcanic soil, a thin, dry carbon dioxide atmosphere, and tracking evidence for ancient river beds and vast flooding. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. There was so much meteorite rain, yet Phobos and Deimos are intact. Air has disappeared from the surface, yet Mars is not in shock. Air has disappeared from the surface, yet Mars is not in shock. There was so much meteorite rain, yet Phobos and Deimos are intact. Air has disappeared from the surface, yet Mars is not in shock. Air has disappeared from the surface, yet Mars is not in shock. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Maybe even water has migrated from the surface to space. Gravitational force still a miracle. Our population saw the world in our dreams. Gravitational force is still a miracle. Our population saw the world in our dreams. Maybe even water has migrated from the surface to space. Gravitational force is still a miracle. Our population saw the world in our dreams. Gravitational force is still a miracle. Our population saw the world in our dreams. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Was ISRO the first to successfully land in Mars orbit? No, ISRO was not the first to successfully land in Mars orbit. They were the fourth space agency to achieve this feat. Following NASA, the Soviet space program, and the European Space Agency. However, ISRO holds the distinction of being the first country to successfully enter Mars orbit on its maiden attempt. Key points about ISRO's Mars mission. Mission name Mars Orbiter Mission MOM, also known as Mangalyaan. Significance: India became the first Asian country to reach Mars orbit. Launch date November 5, 2013. Mars orbit insertion date September 24, 2014. Mars orbit insertion on 24th September 2014 with successfully Mars orbit insertion, ISRO became the fourth space agency to successfully send a spacecraft to Mars orbit, and India became the first country in the world to do so in its first attempt. Mars Orbiter Mission, Indian Space Research Organization, HTTPS www.isro.government.in, Mars Orbiter Mission spacecraft, 18 September 2023. Mars Orbiter Mission MOM, India's first interplanetary mission to planet Mars, was launched on board PSLV C-25 on November 5, 2013. ISRO has become the fourth space agency to successfully send a spacecraft to Mars orbit. Though the design mission life is 6 months, MOM completed 7 years in its orbit on September 24, 2021. Mission objectives. The objectives of this mission are primarily technological and include design, realization and launch of a Mars orbiter spacecraft capable of operating with sufficient autonomy during the journey phase, Mars orbit insertion, capture and in orbit phase around Mars. MOM carries 5 scientific payloads to study the Martian surface, features, morphology, mineralogy and Martian atmosphere. Scientific payloads. Mars continues to be an object of keen interest to scientists in the context of planetary evolution and extraterrestrial life. Based on our understanding of Mars, which was thought to be probably a warm and wet planet earlier, is now seen to be dry with a thin atmosphere. How this evolution has taken place is still a topic of research. In this backdrop, the Indian Mars orbiter mission carried the following 5 scientific payloads: Mars Color Camera (MCC), Thermal Infrared Imaging Spectrometer (TLS), TIS, Methane Sensor for Mars (MSM), Mars Exospheric Neutral Composition Analyzer (MENCA), Lyman Alpha Photometer (LAP). There have been many missions to the Moon and Mars. Just as our Earth has only one moon, Mars has 2 natural satellites, Phobos and Deimos. Earth has one moon, Mars has 2 moons. Moon Phobos, Deimos, these 3 are among the century. Moon Phobos, Deimos, these 3 are among the century. Earth has one moon, Mars has 2 moons. Moons, Phobos, Deimos, these three are among the centuries. Moons, Phobos, Deimos, these three are among the centuries. Mercury, Venus, Earth, Mars, planets for Mons 3. Jupiter, Saturn, Uranus, Neptune, under the Mons only. Jupiter, Saturn, Uranus, Neptune, under the Mons only. Mercury, Venus, Earth, Mars, planets for Mons 3. Jupiter, Saturn, Uranus, Neptune, under the Mons only. Jupiter, Saturn, Uranus, Neptune, under the Mons only. Earth has one moon, Mars has two moons. Mons, Phobos, Deimos, these three are among the centuries. Mons, Phobos, Deimos, these three are among the centuries. Earth has one moon, Mars has two moons. Mons, Phobos, Deimos, these three are among the centuries. Mons, Phobos, Deimos, these three are among the centuries. Near the sun, Mercury, Venus, completely without a moon. Earth started to with one, Mars has to very faint. Earth started with one, Mars is to very faint. Near the sun, Mercury, Venus, completely without a moon. Earth started with one, Mars has to very faint. Earth started with one, Mars has to very faint. Earth has one moon, Mars has two moons. Moons, Phobos, Deimos, these three are among the centuries. Mons, Phobos, Deimos, these three are among the centuries. Earth has one moon, Mars has two moons. Mons, Phobos, Deimos, these three are among the centuries. Mons, Phobos, Deimos, these three are among the centuries. Mercury and Venus being the two closer planets to the Sun. There must have been a weakness in the gravitational pressure. That is why the Moon might not have been able to exist. But the Earth is 93 million miles away from the Sun. So the Moon is probably under pressure from the Earth. Evidence suggests that the Moon was created due to the collision of Theia with the Earth, where Phobos and Deimos of Mars formed from a collision. Yes, it's widely believed that Mars, Moon, Phobos and Deimos were formed from a collision between Mars and protoplanet. Giant impact. A giant impact between Mars and a protoplanet, one third the size of Mars, created a debris disk around the planet. Debris disk. The debris disk had a dense inner part and a thin outer part. Moon formation. The inner part of the disk formed a large moon and gravitational interaction between this moon and the outer ring formed Phobos and Deimos. Common parent body. The moons may have originated from a common parent body that was hit by another object and shattered. Other theories about the formation of Phobos and Deimos include capture. Phobos may be a captured asteroid, primordial moon, Phobos and Deimos may be the remains of a primordial moon that broke apart. The moons of Mars may have started with a huge collision with a protoplanet one third the mass of Mars that formed a ring around Mars. The inner part of the ring formed a large moon. Gravitational interaction between this moon and the other ring formed Phobos and Deimos. Mars moon. NASA science government HTTPS science.nasa government. Mars moons. Moons of Mars. Mars has two moons, Phobos and Deimos. Both are thought to be captured asteroids or debris from early in the formation of our solar system. Phobos is the larger of Mars two moons. It orbits Mars 3 times a day and is so close to the planet's surface that in some locations on Mars it cannot always be seen. Phobos is nearing Mars at a rate of 6 feet 1.8 meters every 100 years up into a ring. Deimos is the smaller moon. It orbits Mars every 30 hours. Phobos is on a collision course with Mars. Deimos is a small and lumpy, heavily created object. Phobos is the larger of Mars two moons and is 17 into 14 into 11 miles, 27 by 22 by 18 kilometers in diameter. It orbits Mars 3 times a day and is so close to the planet's surface that in some locations on Mars it cannot always be seen. Phobos was nearly shattered by a giant impact and has gauges from thousands of meteorite impacts. Phobos is on a collision course with Mars. It's nearing Mars at a rate of 6 feet 1.8 meters every 100 years. At that rate, the moon will either crash into Mars in 50 million years or break up into a ring. Like Phobos, Deimos is a small and lumpy, heavily created object. Its craters are generally smaller than 1.6 miles, 2.5 kilometers in diameter. However, and it lacks the grooves and ridges seen on Phobos. When impacted, dust and debris will leave the surface of the moon because it does not have enough gravitational pull to retain the ejecta. However, the gravity from Mars will keep a ring of this debris around the planet in approximately the same region that the moon orbits. As the moon revolves, the debris is redeposited as a dusty layer on its surface. Deimos has a thick regolith, perhaps as deep as 320 feet 100 meters, formed as meteorites pulverized the surface. Deimos is a dark body that appears to be composed of C-type surface material similar to that of asteroids found in the outer asteroid belt. Earth has one moon marches to moon. Moons for both the most these three are among the century. Moons for both the most these three are among the century. Earth has the one moon marches to moon. Moons for both the most these three are among the century. Moons for both the most these three are among the century. Mercury, Venus, Earth, Mars, planets for moons three. Jupiter, Saturn, Uranus, Neptune, under the moons only. Jupiter, Saturn, Uranus, Neptune, under the moons only. Mercury, Venus, Earth, Mars, planets for moons three. Jupiter, Saturn, Uranus, Neptune, under the moons only. Jupiter, Saturn, Uranus, Neptune, under the moons only. Earth has one moon, Mars has two moons. Moons for both the most, these three are among the century. Moons for both the most, these three are among the century. Earth has one moons has two moons. Moons for both the most, these three are among the century. Moons for both the most, these three are among the century. Near the sun, Mercury, Venus, completely without a moon. Earth started to with one, Mars has to very faint. Earth started with one, Mars has to very faint. Near the sun, Mercury, Venus, completely without a moon. Earth started with one, Mars has to very faint. Earth started with one, Mars has to very faint. Earth has one moon, Mars has two moons. Moons for both the most, these three are among the centuries. Moons for both the most, these three are among the centuries. Earth has one moon, Mars has two moons. Moons for both the most, these three are among the centuries. Moons for both the most, these three are among the centuries. Friends, you know that it is possible that the planet Theia near Mars, our moon, was probably born from the collision of the Earth. But friends, you might not know that the Earth itself was formed by the collision of two nearby bodies, taking the shape of a planet. Was the Earth born from the collision of two bodies? According to the widely accepted giant impact hypothesis, the Earth as we know it today was formed by a massive collision between a proto-Earth and another planetary body, often called Theia, which resulted in the creation of the moon from the debris of the impact. Essentially, Earth was formed from the merging of two bodies through a collision. Key points about this theory: Theia. This hypothetical planet, roughly Mars-sized, is believed to have collided with the early Earth, leading to the formation of the moon debris disk. The impact would have ejected a large amount of material into orbit around the newly formed Earth, which eventually coalesced to create the moon. Evidence supporting the theory: analysis of lunar rocks from Apollo missions suggests a composition similar to Earth, mantle, supporting the idea of a shared origin from a collision. The Earth formed over 4.6 billion years ago out of a mixture of dust and gas around the young sun. It grew larger thanks to countless collisions between dust particles, asteroids, and other growing planets, including one last giant impact that threw enough rock, gas, and dust into space to form the moon. Collision may have formed the moon in mere hours. NASA.government, HTTPS, www.nasa.government, solar system. Collision may have 4 October 2022. Collision may have formed the moon in mere hours. Simulations reveal. Billions of years ago, a version of our Earth that looks very different than the one we live on today was hit by an object about the size of Mars called Theia. And out of that collision, the moon was formed. How exactly that formation occurred is a scientific puzzle. Researchers have studied for decades without a conclusive answer. Most theories claim the moon formed out of the debris of this collision. Coalescing in orbit over months of years, a new simulation puts forth a different theory. The moon may have formed immediately in a matter of hours when a material from the Earth and Theia was launched directly into orbit after the impact. This opens up a whole new range of possible starting places for the moon's evolution, said Jacob Kegris, a postdoctoral researcher at NASA's Ames Research Center in California's Silicon Valley and lead author of the paper on these results published in the Astrophysical Journal Letters. We went into this project not knowing exactly what the outcomes of this high resolution simulations would be. So, on top of the big eye opener that standard resolution can give you misleading answers, it was extra exciting that the new results could include a tantalizingly moon-like satellite in orbit. The simulated lesson used in this research are some of the most detailed of their kind, operating at the highest research resolution of any simulation run to study the moon's origins or other giant impacts. This extra computational power showed that lower resolution simulations can miss out on important aspects of these kinds of collisions, allowing researchers to see new behaviors emerge in a way previous studies just couldn't see. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. There was so much meteorite rain, yet Phobos and Deimos are intact. Air has disappeared from the surface, yet Mars is not in shock. Air has disappeared from the surface, yet Mars is not in shock. There was so much meteorite rain, yet Phobos and Deimos are intact. Air has disappeared from the surface, yet Mars is not in shock. Air has disappeared from the surface, yet Mars is not in shock. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Maybe even water has migrated from the surface to space. Gravitational force still a miracle. Our population saw the world in our dreams. Gravitational force is still a miracle. Our population saw the world in our dreams. Maybe even water has migrated from the surface to space. Gravitational force is still a miracle. Our population saw the world in our dreams. Gravitational force is still a miracle. Our population saw the world in our dreams. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Just like Earth's moon, Mars, Phobos and Deimos were also created. You know friends, Phobos and Deimos do not collide with each other, probably due to a smoky debris between them. Is that debris ring between Mars to moons Phobos and Deimos or a nebula? The debris ring visible between Mars, moons Phobos and Deimos is not a nebula, but rather is theorized to be a ring of dust particles created by impacts on the moons themselves. Not a large scale interstellar cloud like a nebula. Scientists believe Mars might have once had a more substantial ring system that contributed to the formation of its moons, Phobos and Deimos, through debris accretion. Key points to remember: no current ring. While there might be faint dust ring around Phobos and Deimos, Mars does not currently have a visible ring system like Saturn. Origin of the debris, the dust particles likely come from impacts on the moon's surfaces, creating a small debris field in the space between them. Nebula versus debris ring. A nebula is a vast cloud of gas and dust in space, much larger and more diffuse than the small debris ring that might exist around Mars moon. NASA's Hubble sees Martian moon orbiting the red planet. NASA science.government, HDBS science.nasa.government missions. NASA's Hubble sees 20 July 2017. NASA's Hubble sees Martian moon orbiting the red planet. The sharp eye of NASA's Hubble Space Telescope has captured the teeny moon Phobos during its orbital trek around Mars. Because the moon is so small, it appears star-like in the Hubble pictures. Over the course of 22 minutes, Hubble took 13 separate exposures, allowing astronomers to create a time-lapse video showing the diminutive moon's orbital path. The Hubble observations were intended to photograph Mars and the moon's cameo appreciation was a bonus. A football-shaped object just 16.5 miles by 13.5 miles by 11 miles. Phobos is one of the smallest moons in the solar system. It is so teeny that it would fit comfortably inside the Washington DC beltway. The little moon completes an orbit in just 7 hours and 39 minutes, which is faster than Mars rotates. Rising in the Martian west, it runs 3 laps around the red planet in the course of one Martian day, which is about 24 hours and 40 minutes. It is the only natural satellite in the solar system that circles its planet in a time shorter than the planet's day. About 2 weeks after the Apollo 11 manned lunar landing on July 20, 1969, NASA's Mariner 7 flew by the red planet and took the first crowd close-up snapshot of Phobos. On July 20, 1976, NASA's Viking 1 lander touched down on the Martian surface. A year later, its parent craft, the Viking 1 orbiter, took the first detailed photograph of Phobos, revealing a gaping crater from an impact that nearly shattered the moon. Phobos was discovered by Asaph Hall on August 17, 1877 at the U.S. Naval Observatory in Washington, D.C. 6 days after he found the smaller outer moon named Deimos. Hall was deliberately searching for Martian moons. Both moons are named after the sons of Ares, the Greek god of war, who was known as Mars in Roman mythology. Phobos, panic or fear, and Deimos, terror or dread, accompanied their father into battle. Close-up photos from Mars orbiting spacecraft reveal that Phobos is apparently being torn apart by the gravitational pull of Mars. The moon is marred by long, shallow grooves that are probably caused by tidal interactions with its parent planet. Phobos draws nearer to Mars by about 6.5 feet every 100 years. Scientists predict that within 30 to 50 million years, it either will crash into the red planet or be torn to pieces and scattered as a ring around Mars. Orbiting 3,700 miles above the Martian surface, Phobos is closer to its parent planet than any other moon in the solar system. Despite its proximity, observed on Mars would see Phobos at just one third the width of the full moon as seen from Earth. Conversely, someone standing on Phobos would see Mars dominating the horizon, enveloping a quarter of the sky. From the surface of Mars, Phobos can be seen eclipsing the Sun. However, it is so teeny that it does not completely cover our host star. Transits of Phobos across the Sun have been photographed by several Mars-faring spacecraft. The origin of Phobos and Deimos is still being debated. Scientists concluded that the two moons were made of the same material as asteroids. This composition and their irregular shapes led some astrophysicists to theorize that the Martian moons come from the asteroid belt. However, because of their stable, nearly circular orbits, other scientists doubt that the moons were born as asteroids. Such orbits are rare for captured objects which tend to move erratically. An atmosphere could have slowed down Phobos and Deimos and settled them into their current orbits, but the Martian atmosphere is too thin to have circularize the orbit. Also, the moons are not as dense as members of the asteroid belt. Phobos may be a pile of rubble that is held together by a thin crust. It may have formed as dust and rocks encircling Mars were drawn together by gravity. Or it may have experienced a more violent birth where a large body smashing into Mars flung pieces skyward, and those pieces were brought together by gravity. Perhaps an existing moon was destroyed, reduced to the rubble that would become Phobos. Hubble took the images of Phobos orbiting the red planet on May 12, 2016, when Mars was 50 million miles from Earth. This was just a few days before the planet passed closer to Earth in its orbit than it had in the past 11 years. The Hubble Space Telescope is a project of international cooperation between NASA and ESA, European Space Agency. NASA's Goddard Space Flight Center in Green Bay, Maryland manages the telescope. The Space Telescope Science Institute (STSCI) in Baltimore, Maryland conducts Hubble science operations. STSCI is operated for NASA by the Association of Universities for Research in Astronomy (INC) in Washington DC. For images and more information about Hubble, visit https hubblesheet.organization news release news 2017 to 29 www.nasa.government Hubble. Contacts Ann Jenkins, Ray Willard, Space Telescope Science Institute, Baltimore, Maryland 410 338 4488 by 410 338 4514. Jenkins stsci.edu, Willard stsci.edu, Jolt Levy, Space Telescope Science Institute, Baltimore, Maryland 410 338 4907, Happy stsci.edu. However, terrestrial Mars is identified with the help of its two moons, Phobos and Deimos. Terrestrial that Mars, ice particles, rocky dust, seasons to Earth here, atmosphere yellow clear, atmosphere yellow clear, seasons to Earth here, atmosphere yellow clear, atmosphere yellow clear, terrestrial that Mars, ice particles, rocky dust, seasons to Earth here, atmosphere yellow clear, atmosphere yellow clear, seasons to Earth here, atmosphere yellow clear, atmosphere yellow clear, day night collection like here, full rotation to full year, once near Earth, restored again into years, restored again into years, once near Earth, restored again into years, restored again into years, day night collection like here, full rotation to full year, once near Earth, restored again into years, restored again into years, once near Earth, restored again into years, restored again into years, terrestrial that Mars, ice particles, rocky dust, seasons to Earth here, atmosphere yellow clear, atmosphere yellow clear, seasons to Earth here, atmosphere yellow clear, atmosphere yellow clear, terrestrial that Mars, ice particles, rocky dust, seasons to Earth here, atmosphere yellow clear, atmosphere yellow clear, seasons to Earth here, atmosphere yellow clear, atmosphere yellow clear, smaller than Earth by about half, Mars is also habitable, very popular nowadays, so that Alice occurs here, so that Alice occurs here, very popular nowadays. So that at least the curtains here, so that at least the curtains here. Smaller than Earth by about yeah. Mars is the lowest, also habitable, very popular nowadays. So that at least the curtains here, so that at least the curtains here, very popular nowadays. So that at least the curtains here, so that at least the curtains here. Terrestrial, that Mars, ice particles, rocky dust, seasons to earth here, atmosphere yellow clear, atmosphere yellow clear, seasons to earth here, atmosphere yellow clear, atmosphere yellow clear, terrestrial, that Mars, ice particles, rocky dust, seasons to earth here, atmosphere yellow clear, atmosphere yellow clear, seasons to earth here, atmosphere yellow clear, atmosphere yellow clear. If our Earth's moon were two equal moons, it would be approximately the size of Mars. If our moon is one fourth the size of Earth, is Mars one fourth the size of Mars? No, Mars is about half the size of Earth. Diameter, Mars has a diameter of about 4,222 miles, 6,794 kilometers, which is about 53% of Earth's diameter. Mass, Mars has about 1/9 the mass of Earth. Radius, Mars has a radius of about 2,106 miles, 3,390 kilometers. Comparison, if Earth were the size of a nickel, Mars would be about the size of a raspberry. Mars is the seventh largest planet in our solar system. It's the fourth planet from the Sun and orbits at an average distance of 141.6 million miles, 227.9 million kilometers. Mars facts, NASA science, NASA science.government, https science.nasa.government, Mars facts. With a radius of 1,106 miles, 3,390 kilometers, Mars is about half the size of Earth. If Earth were the size of a nickel, Mars would be about as big as a raspberry. Mars, the fourth planet from the Sun, is a dusty, cold desert world with a very thin atmosphere. This dynamic planet has seasons, polar ice caps, extinct volcanoes, canyons and weather. Size and distance. With a radius of 2,106 million miles, 2,106 miles, 3,090 kilometers, Mars is about half the size of Earth. If Earth were the size of a nickel, Mars would be about as big as a raspberry. From an average distance of 142 million miles, 228 million kilometers, Mars is 1.5 astronomical units away from the Sun. One astronomical unit, abbreviated as AU, is the distance from the sun to earth. From this distance, it takes sunlight 13 minutes to travel from the sun to Mars. Terrestrial that Mars, ice particles rocky dark, seasons to earth year, atmosphere yellow clear, atmosphere yellow clear, seasons to earth year, atmosphere yellow clear, atmosphere yellow clear, terrestrial that Mars, ice particles rocky dark, seasons to earth year, atmosphere yellow clear, atmosphere yellow clear, seasons to earth year, atmosphere yellow clear, atmosphere yellow clear, day night collection like air, full rotation to full year, once near earth, restored again into years, restored again into years, once near earth, restored again into years, restored again into years, day night collection like year, full rotation to full year, once near earth, restored again into years, restored again into years, once near earth, restored again into years, restored again into years, terrestrial that Mars, ice particles rocky dark, seasons to earth year, atmosphere yellow clear, atmosphere yellow clear, seasons to earth year, atmosphere yellow clear, atmosphere yellow clear, terrestrial that Mars, ice particles rocky dust, seasons to earth year, atmosphere yellow clear, atmosphere yellow clear, seasons to earth year, atmosphere yellow clear, atmosphere yellow clear, smaller than earth by about half, Mars is also habitable, very popular nowadays, so that at least a curtains here, so that at least a curtains here, very popular nowadays, so that at least a curtains here, so that at least a curtains here, smaller than earth by about half, Mars is the lowest, also habitable, very popular nowadays, so that at least a curtains here, so that at least a curtains here, very popular nowadays, so that at least a curtains here, so that at least a curtains here, terrestrial that Mars, ice particles rocky dark, seasons to earth years, atmosphere yellow clear, atmosphere yellow clear, seasons to earth year, atmosphere yellow clear, atmosphere yellow clear, terrestrial that Mars, ice particles rocky dust, seasons to earth year, atmosphere yellow clear, atmosphere yellow clear, seasons to earth year, atmosphere yellow clear, atmosphere yellow clear. The terrestrial part of the solar system is limited to Mars. Terrestrial means actually rocky parts. Is Mars a rocky surface? Yes, Mars has a rocky surface. Terrestrial planet, Mars is a terrestrial planet, which means it has a compact rocky surface like Earth. Formation, Mars formed about 4.5 billion years ago when gravity pulled in swing gas and dust. Composition: Mars has a central core, a rocky mantle, and a solid crust. Appearance: Mars is one of the easiest planets to spot in the night sky, appearing as a bright red point of light. Moons: Mars moons are made of carbon rich rock mixed with ice and maybe captured asteroids. Frozen caps: Mars has water ice caps that remain frozen year round and seasonal caps of frost that appear in the winter. The planets closest to the Sun, Mars, Earth, Venus, and Mercury, are made mostly of rock. The rocky planets all formed in our inner solar system. Their geological history is preserved on their surfaces. Their landscapes reveal the process that shaped them: impacts, crustal movements, volcanic activity, and erosion. Mars fact: NASA science.government, https science.nasa.government. Mars facts: surrounding the core is a rocky mantle between 770 and 1170 miles, 1240 to 1880 kilometers thick, and above that a crust made of iron, magnesium, aluminum. Surface: the red planet is actually many colors. At the surface we see colors such as brown, gold, and tan. The reason Mars looks reddish is due to oxidation or rusting of iron in the rocks, regolith, Martian soil, and dust of Mars. This dust gets kicked up into the atmosphere and from a distance makes the planet appear mostly red. Interestingly, while Mars is about half the diameter of Earth, its surface has nearly the same area as Earth's dry land. Its volcanoes, impact craters, crustal movement, and atmospheric conditions such as dust storms have altered the landscape of Mars over many years, creating some of the solar system's most interesting topographical features. A large canyon system called Valles Marineris is long enough to stretch from California to New York, more than 3,000 miles, 4,800 kilometers. This Martian canyon is 200 miles, 320 kilometers at its widest, and 4.3 miles, 7 kilometers at its deepest. That's about 10 times the size of Earth's Grand Canyon. Mars is home to the largest volcano in the solar system, Olympus Mons. It's 3 times taller than Earth's empty Everest, with a base the size of the state of New Mexico. Mars appears to have had a quite hairy past. with ancient river, valley networks, deltas and lake beds as well as rocks and minerals on the surface that could only have formed in liquid water. Some features suggest that Mars experienced huge floods about 3.5 billion years ago. There is water on Mars today, but the Martian atmosphere is too thin for liquid water to exist for long on the surface. Today, water on Mars is found in the form of water ice just under the surface in the polar regions as well as in briny, salty water which seasonally flows down some hillsides and crater walls. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. There was so much meteorite rain, yet Phobos and Deimos are intact. Air has disappeared from the surface, yet Mars is not in shock. Air has disappeared from the surface, yet Mars is not in shock. There was so much meteorite rain, yet Phobos and Deimos are intact. Air has disappeared from the surface, yet Mars is not in shock. Air has disappeared from the surface, yet Mars is not in shock. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Maybe even water has migrated from the surface to space. Gravitational force still a miracle. Our population saw the world in our dreams. Gravitational force is still a miracle. Our population saw the world in our dreams. Maybe even water has migrated from the surface to space. Gravitational force is still a miracle. Our population saw the world in our dreams. Gravitational force is still a miracle. Our population saw the world in our dreams. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. What is the difference between terrestrial and gaseous giants? A terrestrial planet, also called a rocky planet, is primarily composed of rock and metal, has a solid surface and is typically smaller, while a gaseous giant is a large planet made up mostly of gas like hydrogen and helium, with no clear solid surface and a much larger size compared to a terrestrial planet Essentially, terrestrial planets are like Earth, while gas giants are like Jupiter. Key differences: composition. Terrestrial planets are made of rock and metal, while gas giants are primarily composed of hydrogen and helium gas. Surface: terrestrial planets have a solid surface, whereas gas giants do not have a defined surface, meaning there is no clear boundary between the atmosphere and the surface. Size: gas giants are significantly larger than terrestrial planets. Example: terrestrial planets Mercury, Venus, Earth and Mars. Gas giants Jupiter, Saturn, Uranus and Neptune. A gas giant is a giant planet that is made of gas. They are different from rocky or terrestrial planets that are made of mostly rock. Unlike rocky planets, gas giants do not have a well-defined surface. There is no clear boundary between where the atmosphere ends and the surface starts. How are the gas giants different from the terrestrial planets? Socratic. ACD-based Socratic.organization questions how are the gas giants. 25 November 2015. How are the gas giants different from the terrestrial planets? Astronomy. Composition, size. Explanation: gas giants, Jovian planets, are also called the outer planets. They are made of gases. They are large and less dense. More moons. Terrestrial rocky planets are also called the inner planets. They are made of rocky surface, denser than Jovians and small, little or no moons. The surprising thing is that the terrestrial world is only 142 million miles from the sun. After 484 million miles from the sun, the gaseous giants begin, and the distance from the earth is 93 million miles. Naturally, the distance from Mars is 142 million miles. From the side of the sun, the earth is 93 million miles away. It is further than that 142 million miles across Mars. It is further than that 142 million miles across Mars. From the side of the sun, the earth is 93 million miles away. It is further than that 142 million miles across Mars. It is further than that 142 million miles across Mars. 50 million miles from Earth. Mars may even be 250 million miles away. Distance between Earth and Mars. Solar eclipse, sometimes Mars eclipse. Distance between Earth and Mars. Solar eclipse, sometimes Mars eclipse. 50 million miles from Earth. Mars may even be 250 million miles away. Distance between Earth and Mars. Solar eclipse, sometimes Mars eclipse. Distance between Earth and Mars. Solar eclipse, sometimes Mars eclipse. From the side of the sun, the Earth is 93 million miles away. It is further than that 142 million miles across Mars. It is further than that 142 million miles across Mars. From the side of the sun, the earth is 93 million miles away. It is further than that 142 million miles across Mars. It is further than that 142 million miles across the Mars. Between Mars and the Sun, someday the Earth comes. Between Earth and the Mars, the Sun also makes it grow further. Between Earth and the Mars, the Sun also makes it grow further. Between Mars and the Sun, someday the Earth comes. Between Earth and Mars, the Sun also makes it grow further. Between Earth and Mars, the Sun also makes it grow further. From the side of the Sun, the Earth is 93 million miles away. It is further than that, 142 million miles across the Mars. It is further than that, 142 million miles across the Mars. From the Sun of the side, the Earth is 93 million miles away. It is further than that, 142 million miles across the Mars. It is further than that, 142 million miles across the Mars. Sun is a constellation which is kept in its center, and planets revolve around it by making orbits, where Earth is also present and Earth's near neighbor Mars is also present. Earth and Earth's near neighbor Mars, while revolving in their orbits, sometimes make a distance of 49 to 50 million miles and sometimes even 250 million miles. The closest distance between Earth and Mars is 49 million miles. When do Earth and Mars come in close distance again after crossing the close distance 1? According to current estimates, Earth and Mars will next come as close as they did in their most recent close approach, which occurred in 2003. Around the year 2287. This means that after a close encounter, it will be roughly 280 years until they are that close again. Key points about Earth and Mars close approaches. Closest recorded distance in August 2003, Earth and Mars were only 34.8 million miles apart, marking the closest they have been in nearly 60,000 years opposition. This close approach typically happens when Mars is in opposition, meaning Earth is directly between Mars and the Sun. Frequency. While Mars and Earth come relatively close every couple of years, the exceptionally close encounters like the 2003 event occur much less frequently. Mars facts. NASA science.government, https science.nasa.government. Mars facts. Orbit and rotation. As Mars orbits the Sun, it completes one rotation every 24.6 hours, which is very similar to one day on Earth, 23.9 hours. Martian days are called sols, short for solar day. A year on Mars lasts 669.6 sols, which is the same as 687 Earth days. Mars axis of rotation is tilted 25 degrees with respect to the plane of its orbit around the sun. This is another similarity with Earth, which has an axial tilt of 23.4 degrees, like Earth. Mars has distinct seasons, but they last longer than season here on Earth, since Mars takes longer to orbit the Sun because it's further away, and while here on Earth the seasons are evenly spread over the year, lasting 3 months or 1/4 of a year. On Mars, the seasons vary in length because of Mars' elliptical egg-shaped orbit around the Sun. Spring in the northern hemisphere, autumn in the southern, is the longest season at 194 sols. Autumn in the northern hemisphere, spring in the southern, is the shortest at 142 days. Northern winter, southern summer is 154 sols, and northern summer, southern winter is 178 sols. Mars has magnetosphere. Mars has no global magnetic field today, but areas of the Martian crust in the southern hemisphere are highly magnetized, indicating traces of a magnetic field from 4 billion years ago. From the side of the sun, the earth is 93 million miles away. It is further than that 142 million miles across Mars. It is further than that 142 million miles across Mars. From the side of the sun, the earth is 93 million miles away. It is further than that 142 million miles across Mars. It is further than that 142 million miles across Mars. 50 million miles from Earth. Mars may even be 250 million miles away. Distance between Earth and Mars. Solar eclipse, sometimes Mars eclipse. Distance between Earth and Mars. Solar eclipse, sometimes Mars eclipse. 50 million miles from Earth. Mars may even be 250 million miles away. Distance between Earth and Mars. Solar eclipse, sometimes Mars eclipse. Distance between Earth and Mars. Solar eclipse, sometimes Mars eclipse. From the side of the sun, the Earth is 93 million miles away. It is further than that 142 million miles across Mars. It is further than that 142 million miles across Mars. From the side of the sun, the earth is 93 million miles away. It is further than that 142 million miles across Mars. It is further than that 142 million miles across Mars. Between Mars and the sun, someday the earth comes. Between earth and Mars, the sun also makes it grow further. Between earth and Mars, the sun also makes it grow further. Between Mars and the sun, someday the earth comes. Between earth and Mars, the sun also makes it grow further. Between earth and Mars, the sun also makes it grow further. From the side of the sun, the earth is 93 million miles away. It is further than that 142 million miles across Mars. It is further than that 142 million miles across the Mars. From the sun of the side, the Earth is 93 million miles away. It is further than that 142 million miles across the Mars. It is further than that 142 million miles across the Mars. The distance of the Earth from the Sun is 93 million miles, which we call one astronomical unit. The distance of Mars from the Sun is 142 million miles, and the distance of Jupiter from the Sun is 484 million miles. Up to 142 million miles from the Sun, the four planets Mercury, Venus, Earth and Mars are included in the terrestrial mantle. Then from 484 million miles, the Sun's gaseous giant mantle body starts, which is Jupiter, Saturn, Uranus and Neptune. Within 142 million miles and 484 million miles from the Sun, there is a ring-like belt consisting of smoke, dust, particles, meteorites, comets and a lot of asteroids, which we know as the asteroid belt. What is the distance of the ring-like asteroid belt from the Sun? The asteroid belt is located between 2.2 and 3.2 astronomical units AU from the Sun, meaning it is roughly 329 million to 478.7 million kilometers away from the Sun. This is situated between the orbits of Mars and Jupiter. Key points about the asteroid belt: distance range 2.2 to 3.2 AU. Location between Mars and Jupiter. 1 AU represents the average distance between Earth and the Sun. However, planets are not the only things that orbit the Sun. Around 330 million kilometers away from the Sun, between the orbits of Mars and Jupiter, is region of gravitationally accreted rocky bodies, or what is known as the asteroid belt. Asteroids fact: NASA, science.government, https science.nasa.government, solar system, asteroids fact, introduction. Most asteroids can be found orbiting our Sun between Mars and Jupiter. Within the main asteroid belt, asteroids range in size from Vesta, the largest asteroid at about 329 miles, 530 kilometers in diameter, to bodies that are less than 33 feet 10 meters. Across the total mass of all the asteroids combined is less than that of Earth's moon. Sometimes asteroids and comets are dragged into Earth's neighborhood by the gravity of nearby planets. These objects are called near-Earth objects of NEOs, NEOs. There are more than 35,000 NEOs according to the Center for Near-Earth Object Studies, CNEOS, at NASA's Jet Propulsion Laboratory, JPL. About 99% of NEOs are asteroids. Their closest approach to the Sun is less than 1.3 times Earth's distance from the Sun. Asteroid classification. Main asteroid belt. The majority of known asteroids orbit within the asteroid belt between Mars and Jupiter, generally with not very elongated orbits. The belt is estimated to contain between 1.1 and 1.9 million asteroids larger than 1 kilometer, 0.6 miles in diameter, and millions of smaller ones. Early in the history of the solar system, the gravity of newly formed Jupiter brought an end to the formation of planetary bodies in this region and caused the small bodies to collide with one another, fragmenting them into the asteroid we observe today. Trojans. These asteroids share an orbit with a larger planet but do not collide with it because they gather around two special places in the orbit called the L4 and L5 Lagrangian points. They are the gravitational pull from the Sun and the planet are balanced by a Trojan's tendency to otherwise fly out of orbit. The Jupiter Trojans form the most significant population of Trojan asteroids. It is thought that they are as numerous as the asteroids in the asteroid belt. There are Mars and Neptune Trojans, and NASA announced the discovery of an Earth Trojan in 2011. Near Earth asteroids, these objects have orbits that pass close by that of Earth. Asteroids that actually cross Earth's orbital path are known as Earth crossers. Fourth planet from the Sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the Sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. There was so much meteorite rain, yet Phobos and Deimos are intact. Air has disappeared from the surface, yet Mars is not in shock. Air has disappeared from the surface, yet Mars is not in shock. There was so much meteorite rain, yet Phobos and Deimos are intact. Air has disappeared from the surface, yet Mars is not in shock. Air has disappeared from the surface, yet Mars is not in shock. Fourth planet from the Sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the Sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Maybe even water has migrated from the surface to space. Gravitational force still a miracle. Our population saw the world in our dreams. Gravitational force is still a miracle. Our population saw the world in our dreams. Maybe even water has migrated from the surface to space. Gravitational force is still a miracle. Our population saw the world in our dreams. Gravitational force is still a miracle. Our population saw the world in our dreams. Fourth planet from the sun. News of the red planet. No air, no water. Yet the gravitational force is tremendous. No air, no water. Yet the gravitational force is tremendous. Fourth planet from the sun. News of the red planet. No air, no water. Yet the gravitational force is tremendous. No air, no water. Yet the gravitational force is tremendous. Within that thick belt, which stretches from about 330 million kilometers from the sun to 475.7 million kilometers, there must be occasionally collisions between fast moving and slow moving asteroids. Does not the disturbance of Mars or the solar system occur due to the bodies scattered from the asteroid belt? Do comets or asteroids scattered from the asteroid belt set off a chain of collisions in the solar system? Yes, asteroids scattered from the asteroid belt primarily due to the gravitational influence of Jupiter can set off chain reactions of collisions within the solar system, where one collision can produce debris that then collides with other objects, creating a cascade of impacts across different planetary regions. This is especially true in the early stages of solar system formation when the density of objects was much higher. Key points about this phenomenon: Jupiter's role. Jupiter's strong gravity significantly affects the asteroid belt, often flinging asteroids out of their original orbits and potentially towards the other planets or moons. Collision fragments. When asteroids collide, they break apart into smaller fragments which can then collide with other objects, creating a chain reaction. Impact craters. Evidence of these collisions can be seen on planets and moons as impact craters, comets and chain reactions. While comets can also collide with other objects, their highly elliptical orbits make them less likely to initiate sustained chain reaction within the asteroid belt compared to asteroids. Asteroid belts at just the right place are friendly to life. NASA Jet Propulsion Laboratory .government. HTTPS www.jpl.nasa.government. News: asteroid belts at just 1 November 2012. Asteroid belts at just the right place are friendly to life. Solar systems with life-bearing planets may be rare if they are dependent on the presence of asteroid belts of just the right mass, according to a new study. Pasadena, Calif. Solar systems with the life-bearing planets may be rare if they are dependent on the presence of a asteroid belts of just the right mass. According to a study by Rebecca Martin, a NASA Sagan Fellow from the University of Colorado in Boulder, and astronomer Mario Livio of the Space Telescope Science Institute in Baltimore, MD, they suggest that the size and location of an asteroid belt shaped by the evolution of the sun's planet forming this and by the gravitational influence of a nearby giant Jupiter like planet may determine whether complex life will evolve on an Earth like planet. This might sound surprising because asteroids are considered a nuisance due to their potential to impact Earth and trigger mass extinction, but an emerging view proposes that asteroid collisions with planets may provide a boost to the birth and evolution of complex life. Asteroids may have delivered water and organic compounds to the early Earth. According to the theory of punctuated equilibrium, occasional asteroid impacts might accelerate the rate of biological evolution by disrupting a planet's environment to the point where species must try new adaptation strategies. The astronomers based their conclusion on an analysis of theoretically models and archival observations, including infrared data from NASA's Spitzer Space Telescope. Our study shows that only a teeny fraction of planetary systems observed to date seem to have giant planets in the right location to produce an asteroid belt of the appropriate size, offering the potential for life on a nearby rocky planet, said Martin, the study's lead author. Our study suggests that our solar system may be rather special. The findings will appear today in the monthly notices of the Royal Astronomical Society letters. Martin and Livio suggest that the location of an asteroid belt relative to a Jupiter-like planet is not an accident. The asteroid belt in our solar system, located between Mars and Jupiter, is a region of millions of space rocks that sits near the snow line, which marks the border of a cold region where volatile material such as water, ice is far enough from the sun to remain intact. When Jupiter formed just beyond the snow line, its powerful gravity prevented nearby material inside its orbit from collapsing and building planets. Instead, Jupiter's influence caused the material to collide and break apart. These fragmented rocks settled into an asteroid belt around the Sun. To have such ideal conditions, you need a giant planet like Jupiter that is just outside the asteroid belt and that migrated a little bit but not through the belt. Livio explained, if a large planet like Jupiter migrates through the belt, it would scatter the material. If on the other hand a large planet did not migrate at all, that too is not good because the asteroid belt would be too massive. There would be so much bombardment from asteroids that life may never evolve. Using our solar system as a model, Martin and Livio proposed that asteroid belts in other solar systems would always be located approximately at the snow line. To test their proposal, Martin and Livio created models of planet-forming disks around young stars and calculated the location of the snow line in those disks based on the mass of the central star. They then looked at all the existing space based infrared observations from the Spitzer Space Telescope of 90 stars having warm dust which could indicate the presence of an asteroid belt-like structure. The temperature of the warm dust was consistent with that of the snow line. The warm dust falls right into onto our calculated snow lines, so the observations are consistent with our predictions, Martin said. The duo then studied observations of the 520 giant planets found outside our solar system. Only 19 of them reside outside the snow line. This suggests that most of the giant planets that may have formed outside the snow line have migrated too far inward to preserve the kind of slightly dispersed asteroid belt needed to foster enhanced evolution of life on an Earth-like planet near the belt. Apparently, less than 4% of the observed systems may actually harbor such a compact asteroid belt. Based on our scenario, we should concentrate our efforts to look for complex life in systems that have a giant planet outside of the snow line, Livio said. The second fellowship program is administered by the NASA Exoplanet Science Institute at the California Institute of Technology in Pasadena, California, whose purpose is to advance the scientific and technical goals of NASA's exoplanet exploration program. The exoplanet exploration program is managed for NASA by NASA's Jet Propulsion Laboratory in Pasadena, California. Caltech manages JPL for NASA. More information about exoplanets and NASA's planet finding program is at http planetquest.jpl.nasa.government. JPL manages the Spitzer Space Telescope mission for NASA's science mission Directorate, Washington. Science operations are conducted at the Spitzer Science Center at Caltech. Data are archived at the Infrared Science Archive housed at the Infrared Processing and Analysis Center at Caltech. For more information about Spitzer, visit http spitzer.caltech.edu and http www.nasa.government Spitzer. News media contact Whitney Clavin, Caltech 626 395 1944. Clavin, Caltech.edu. Cheryl S. Gundi 410 338 4707. Gundi STSCI.edu 2012 2345. By the way, Earth itself is also a Trojan. Well, after Earth, there is the paradise of Mars. After Earth, paradise of Mars revolves around the sun. Day and night, year of 25 hours. Full rotation but facing the earth for 2 years. Full rotation but facing the earth for 2 years. After Earth, paradise of Mars revolves around the sun. Day and night, year of 25 hours. Full rotation but facing the earth for 2 years. Full rotation but facing the earth for 2 years. Is the one of the century. This sequence, otherwise it might have happened. The earth is till today at the same place. It is appropriate for Mars to say. It is appropriate for Mars to stay. Is the one of the century. This sequence, otherwise it might not have happened. The earth is till today at the same place. It is appropriate for Mars to stay. It is appropriate for Mars to stay. After Earth, paradise of Mars revolves around the sun. Day and night are of 25 hours. Full rotation but facing the earth for 2 years. Full rotation but facing the earth for 2 years. After Earth, paradise of Mars revolves around the sun. Day and night are of 25 hours. Full rotation but facing the earth for 2 years. Full rotation but facing the earth for 2 years. Then was no collision. Billion of trillions of years have passed. Mars paired to there. In between the planet Thea collided at the beginning and Thea's journey was uneventful. Thea's journey was uneventful. There was no collision. Billions of trillions of years have passed. Mars, Earth to there. In between the planet Thea collided at the beginning and Thea's journey was uneventful. Thea's journey was uneventful. After Earth, paradise of Mars revolves around the sun. Day and night are of 25 hours. Full rotation but facing the earth for 2 years. Full rotation but facing the earth for 2 years. after a paradise of a Mars revolves around the sun. Day and night a ray of 25 hours. Full rotation but facing the earth for 2 years. Full rotation but facing the earth for 2 years. It is said that billions of years ago, a huge planet called Theia used to revolve around the sun between Mars and Earth. Know how planet Theia collided with Earth while revolving around the sun, and that journey of planet Theia between Mars and Earth had become extinct from the entire solar system right from the beginning. Did the solar system really have 9 planets? Which planet Theia? The solar system currently has 8 planets, but there is a possibility that there was once a 9th planet. Current planets, the 8 planets in our solar system are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. Possible 9th planet in 2016, researchers proposed the existence of a 9th planet dubbed Planet 9 or Planet X. This planet is estimated to be around 10 times the mass of Earth and to orbit the Sun between 300 and 1000 times further than Earth. However, scientists have not yet seen Planet 9. Theia. Theia may have been a planet that collided with Earth in a violent event. Some believe that fragments of Theia may be found deep in Earth's mantle. Computer simulations in 2023 reinforced this hypothesis. 4.5 billion years ago, another planet crashed into Earth. We, National Geographic, HTTPS, www.nationalgeographic.com, premium article, 1 November 2023. A new study suggests that portions of the moon forming impactor Theia survived throughout Earth's history deep in our planet's mantle. 9 ghostly planets. Britannica, HTTPS, www.britannica.com, Demystified Science. Humanity has sent probes to every planet, so we now have a decent idea of what's in our neighborhood. Even before that, astronomers tracked the movements of the solar system for millennia. Sometimes their eyes or brains played thick tricks, or did they? Whatever happened to the ghost planets, those worlds that never existed or once were but are no longer? Theia. The origin of the moon was long a mystery, and beginning in the 19th century, their competing theories emerged to solve it. In one, Earth and the moon formed together in the same spot in the primordial solar nebula. In another, the early earth spun so fast that it hurried, hurled out a blob that became the moon. One version of this theory held that the Pacific Ocean is the hole left behind. In the third, the moon formed elsewhere but was captured by Earth. However, none of these theories could adequately explain the current Earth Moon system. In the 1970s, a new proposal emerged that a giant impact had formed the moon. The impactor would have been the size of Mars and was given the name Theia after the mother of Selena, the Greek moon goddess. In the impact, Theia was destroyed and the debris became the moon. The debris may even have formed two moons, one smaller than the other. They eventually collided very slowly in what is described as something like a large landslide. The landslide site became what is now the moon's far side, and this theory would explain why the near and far-sided sides of the moon are so different. After a paradise of Mars revolves around the sun, day and night, year of 25 hours. Full rotation but facing the earth for 2 years. Full rotation but facing the earth for 2 years. After a paradise of Mars revolves around the sun. Day and night, year of 25 hours. Full rotation but facing the earth for 2 years. Full rotation but facing the earth for 2 years. Is one of the century. This sequence, otherwise it might not have happened. The earth is till today at the same place. It is appropriate for Mars to say. It is appropriate for Mars to stay. Is one of the century. This sequence, otherwise it might not have happened. The earth is till today at the same place. It is appropriate for Mars to stay. It is appropriate for Mars to stay. After a paradise of Mars revolves around the sun. Day and night are of 25 hours. Full rotation but facing the earth for 2 years. Full rotation but facing the earth for 2 years. After a paradise of Mars revolves around the sun. Day and night are of 25 hours. Full rotation but facing the earth for 2 years. Full rotation but facing the earth for 2 years. Then was no collision. Billion of billions of years have passed. Mars paired to there. In between the planet Theia collided at the beginning and Theia's journey was uneventful. Theia's journey was uneventful. There was no collision. Billions of years have passed. Mars, Earth to there. In between the planet Theia collided at the beginning and Theia's journey was uneventful. Theia's journey was uneventful. After a paradise of Mars revolves around the sun. Day and night are up with 25 hours. Full rotation but facing the earth for 2 years. Full rotation but facing the earth for 2 years. After a paradise of Mars revolves around the sun. Day and night are up with 25 hours. Full rotation but facing the earth for 2 years. Full rotation but facing the earth for 2 years. Mars is paradise after Earth. Friends, you know that after Earth, no evidence of any life with respiratory system or any alien life like Luca has been found in the entire galaxy till now. But an amazing research is saying that maybe life existed on Mars about 3 billion years ago. Did life ever exist on Mars? There is no conclusive evidence that life ever existed on Mars, but there is evidence that Mars may have been habitable for microorganisms in the past. Evidence of a habitable past. There's evidence that Mars had liquid water and an atmosphere that could have supported life during the Noachian period. Loss of habitability. Mars lost its magnetic field and nearly all of its atmosphere, making it uninhabitable. This change may have taken hundreds of millions of years. Current conditions. Mars is now a cold, dry desert with an average temperature of minus 80 degree Fahrenheit, minus 60 degree Celsius. Search for life. NASA's Perseverance rover is searching for evidence of past life in a former Martian crater that was once filled with water. The rover is also collecting samples of rock and surface material to return to Earth. Potential for life in the surface. Some places underground on Mars could be habitable as they are protected from the harmful radiation on the surface. To date, no conclusive evidence of past or present life has been found on Mars. Cumulative evidence suggests that during the ancient Noachian time period, the surface environment of Mars had liquid water and may have been habitable for microorganisms, but habitable conditions do not necessarily indicate life. Was there life on Mars? NASA Science.Government, https science.nasa.government blog. Was there life on Mars? At 28 November 2023. Was there life on Mars? Astrobiology is the study of the origin, evolution and distribution of life in the universe, and searching for life on Mars is a major goal of the Mars 2020 mission. While humans have long wondered whether there are others like us, it's only been a few decades since we have developed the technologies to search for life beyond Earth in earnest. With space-based telescopes like James Webb, astronomers look up for planetary scale chemical signs of life on exoplanets. With ground-based radio astronomy, astrophysics listen for signals or communications transmitted by intelligent species from galaxies far away, and with landed missions to Mars and other solar system bodies, planetary scientists and geologists look down for physical and chemical signs of life preserved in rock and ice. Finding extraterrestrial life is a central aspect of astrobiology, but finding no life on a once habitably rocky planet like Mars would be equally important, because it would help us look back into our own origins to query what makes Earth biologically unique, and would also help us prepare to search for life elsewhere. Jezero crater was selected as the Mars 2020 landing site because of its astrobiological potential. Billions of years ago, it hosted a lake back when Mars was warm and wet, more hospitable, and Earth-like water is essential for life as we know it. And sedimentary rocks that form through aqueous activity can be excellent physical preservers of biological materials. Perseverance has also found evidence for igneous minerals, and these lithologies can be important for life as well. On Earth, volcanic rocks provide energy rich substance for microbes to feed upon and inhabit. If ancient organisms could still remain as morphological, elemental or molecular biosignatures preserved in rock today. To aid in this search, perseverance carries a suite of on-board instruments to select astrobiologically interesting samples to send back to Earth. 23 crores have been collected thus far. Robotic rover tools can reveal a lot about potential for habitability, but returning physical samples is absolutely critical for determining whether these rocks do contain evidence of life. For example, billion-year-old cells and fossilized biomolecules preserved in geologic samples on Earth are studied with large complex analytical instruments housed in laboratories. Returning cores from Jezero will allow scientists to apply the same techniques to extraterrestrial samples too. Regardless of what we find, searching for life in these little Martian rocks represents an astronomical leap towards determining whether there was life on Mars, which will in turn give us a better understanding of who we are, where we came from, and where we are going. Written by Dennis Buckner, student collaborator at University of Florida. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. There was so much meteorite rain, yet Phobos and Deimos are intact. Air has disappeared from the surface, yet Mars is not in shock. Air has disappeared from the surface, yet Mars is not in shock. There was so much meteorite rain, yet Phobos and Deimos are intact. Air has disappeared from the surface, yet Mars is not in shock. Air has disappeared from the surface, yet Mars is not in shock. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Maybe even water has migrated from the surface to space. Gravitational force still a miracle. Our population saw the world in our dreams. Gravitational force is still a miracle. Our population saw the world in our dreams. Maybe even water has migrated from the surface to space. Gravitational force is still a miracle. Our population saw the world in our dreams. Gravitational force is still a miracle. Our population saw the world in our dreams. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. If there is no evidence of existence of life on Mars in the present or past, then why is Mars being considered a paradise? What is the reason to believe that there might have been microorganisms on Mars? There are a number of reasons to believe that microorganisms may have existed on Mars, including organic molecules. In 2018, NASA's Curiosity rover found organic molecules in sedimentary rocks that are 3 billion years old. These molecules are some of the building blocks for life. Impacting type. This material was discovered on Mars and can preserve signs of life on Earth. Microbial fossils. In 1996, scientists studying a Martian meteorite found structures that looked like microbial fossils similar to those found on Earth. Methane. The Curiosity rover detected methane in Gale crater, an environment where methanogenic archaea type microorganisms might still survive. Underground water. Data suggests that there is a large volume of water locked up in rocks between 11.5 and 20 kilometers below the surface of Mars. This opens up the possibility of underground life on Mars, the confirmation that liquid water once flowed on Mars. The existence of nutrients and the previous discovery of a vast magnetic field that protect the planet from cosmic and solar radiation together strongly suggest that Mars could have had the environmental factors to support life. Could humans have contaminated Mars with life? BBC, HTTPS, www.bbc.com, Future article 2021-0510 COU 10 May 2021. Could humans have contaminated Mars with life? Humanity has sent around 30 spacecraft and landers to the red planet since the space age began. Now we know which microbes might have survived the trip, says genetist Christopher Mason, trundling across the surface of Mars. As you read, this is a remarkable machine. Perseverance, the car-sized rover, Perseverance, the car-sized rover that safely touched down on the Martian surface on 18 February this year, might only have a top speed of less than 0.1 miles per hour, 152 mile per hour, but it carries a wide range of tools, instruments and experiments that have already made some groundbreaking achievements. Included on board the 10 feet long 3-meter rover is a machine that has turned the thin carbon dioxide rich Martian air into oxygen, and a helicopter the size of a tissue box that made the first ever powered controlled flight on another planet. The helicopter, called Ingenuity, has now made 3 successful flights, each longer and higher than the last. But did anything else come along for a ride with all this hardware? Could a trace bacterium or spore from Earth have accidentally been carried into space and survived the trip to make its new home on Mars. NASA and its engineers in the Jet Propulsion Laboratory (JPL) have precise and thorough protocols to minimize the number of organisms that might inadvertently hitchhike on a space mission. Internationally agreed standards quite how rigorous these protocols should be, and NASA meets and in some cases exceeds them. Yet two recent studies highlight how some organisms might survive the cleaning process and also the trip of Mars, and also how fast microbial species can evolve while in space. First, let's start with the process that was required to build the Perseverance rover, as well as most spacecraft made in JPL Spacecraft Assembly Facility (SAF). Their spacecraft are painstakingly built one layer at a time, like an onion, with everything cleaned before it is added. These methods limit the bacteria, viruses, fungi, or spores on equipment to be sent on a mission. Spacecraft are built rooms with air filters and strict biological control procedures. These are designed to ensure that only a few hundred particles can contaminate each square foot, and ideally no more than a few dozen spores per square meter. But it is almost impossible to get to zero biomass on a spacecraft. Microbes have been on Earth for billions of years, and they are everywhere. They are inside us, on our bodies, and all around us. Some can sneak through even the cleanest of clean rooms. In the past, tests for biological contamination have relied upon the ability to grow, often called culturing, life from samples swabbed from equipment. The newer methods used by my colleagues and I take a given sample, extract all the DNA, and then shotgun sequence it. As the term implies, it is like taking a shotgun to the cells of a sample, blasting them into billions of sample DNA fragments, and then sequencing each piece. Each piece or sequence read can then be mapped back to the known genomes of species that are already present in sequence databases. Since we can now sequence all the DNA that is present in the clean rooms and not just the ones that could be cultured, we get a more comprehensive look at what kind of microbes can be found in the clean room, and if they could even survive the vacuum of space In JPL's clean rooms, we found evidence of microbes that have the potential to be problematic during space missions. These organisms have increased numbers of genes for DNA repair, giving them greater resistance against radiation. They can form biofilms on surfaces and equipment, can survive desiccation and thrive in cold environments. It turns out that clean rooms might have served as an evolutionary selection process for the hardiest bugs that then may have a greater chance of surviving a journey to Mars. These findings have implications for a form of planetary protection called forward contamination. This is where we might bring something accidentally or on purpose to another planet. It is important to ensure the safety and preservation of any life that might exist elsewhere in the universe. Since new organisms can wreak havoc when they arrive at a new ecosystem, humans have a poor track record of this on our own planet. Smallpox, for example, was spread on blankets given to indigenous people of North America in the 19th century. Even in 2020, we have been unable to contain the rapid spread of the virus that causes COVID-19, SARS COVID-2. In fact, since the surface of Mars is made up of rust and iron mixed soil, NASA was looking for the existence of life forms like the Luca class of Earth. Mars is already a familiar planet with a rich atmosphere of red, yellow smoke and dust. Red, yellow, smoke, dust, atmosphere of Mars. No water, no soil, surface dusty iron details. No water, no soil, surface dusty iron details. Red, yellow, smoke, dust, atmosphere of Mars. No water, no soil, surface dusty iron details. No water, no soil, surface dusty iron details. Many craters everywhere. Some dry, some crystal. So there are four seasons, autumn, summer, winter, spring. So there are four seasons, autumn, summer, winter, spring. Many craters everywhere, some dry, some crystals. So there are four seasons, autumn, summer, winter, spring. So there are four seasons, autumn, summer, winter, spring. Red, yellow, smoke, dust, atmosphere of Mars. No water, no soil, surface dust, air and details. No water, no soil, surface dust, air and details. Radial smoke, dust, atmosphere of Mars. No water, no soil, surface dust, air and dust, details. No water, no soil, surface dust, air and details. Crater JJ Rogel, our identity. Perseverance, curiosity, where took the help of landing. Perseverance, curiosity, who took the help of landing. Crater JJ Rogel, our identity. Perseverance, curiosity, who took the help of landing. Perseverance, curiosity, who took the help of landing. Radio low smoke dust, atmosphere of Mars. No water, no soil, surface dust, air and details. No water, no soil, surface dust, air and details. Radial smoke dust, atmosphere of Mars. No water, no soil, surface dusty, iron details. No water, no soil, surface dusty, iron details. You know, friends, it is the craters of Mars that gave us the craze to know about Mars. By the way, there are many craters present on Mars. Among those craters, the most famous are Jezero and Gale craters, where NASA's Perseverance Curiosity rover landed. Did NASA name Jezero and Gale craters? Yes, NASA named both Jezero crater and Gale crater on Mars. Jezero crater, named after a Bosnian town. Jezero crater is a crater on Mars that was once a lake. NASA's Perseverance rover landed in Jezero crater to study the region's formation and evolution and in and to search for signs of ancient life. Gale crater, the landing site of NASA's Curiosity rover. NASA names many places on Mars, including craters larger than 37 miles in diameter, which are named after famous scientists or science fiction authors. Smaller craters are named after towns with populations of less than 100,000. NASA gives name to every spot it studies on Mars. NASA.government, HTTPS www.nasa.government, solar system, why and how, NASA, 8 June 2023. Why and how NASA gives a name to every spot it studies on Mars. Martian maps are full of monikers recognizing places on Earth. Explorers and even cartoon characters. NASA's Perseverance rover is currently investigation rock outcrops alongside the rim of Mars. Beleva crater, some 2,300 miles, 3,700 kilometers away. NASA's Curiosity rover recently drilled a sample at a location called Ubajara. The crater bears on an official name. The drill location is identified by a nickname. Hence, the quotation marks. Both names are among thousands applied by NASA missions, not just to craters and hills, but also to every boulder, pebble and rock surface they study. The number one reason we pick all these names is to help the team keep track of what they are finding each day, said Ashin Vasavada, the Curiosity Missions project scientist at NASA's Jet Propulsion Laboratory in Southern California. Later on, we can refer to the many hills and rocks by name as we discuss them and eventually document our discoveries. Just how scientists come up with the identifiers has evolved since the early days 25 years ago when they used cartoon character names. Here's a close look. Official names. The difference between an official name on Mars and an unofficial one is seemingly simple. Official monikers have been approved by a body of scientists known as the International Astronomical Union IAU. The IAU sets standard for naming planetary features and logs the names in the Gazetteer of Planetary Nomenclature. For example, craters larger than 37 miles 60 kilometers are named for famous scientists or science fiction authors. Smaller craters are named after towns with populations of less than 100,000 people. Jezero crater, which Perseverance has been exploring, shares the name from a Bosnian town, Belva. And impact crater within Jezero is named after a West Virginia town that is in turn named after Belva Lockwood, the suffragist who ran for president in 1884 and 1888. More than 2,000 locations on Mars bear official names, but even more unofficial nicknames dot the Martian map. Evolving nicknames. Early Mars missions sometimes Luke took a whimsical route with nicknames, even using cartoon characters' names. Yogi, Rock, Caspar, and Scooby Doo were among the unofficial names applied by the team behind NASA's first rover, Sojourner. In the late 1990s, the philosophy changed with the Spirit and Opportunity rovers, whose teams started using more intentional names. For instance, the Opportunity team nicknamed a crater Endurance to honor the ship that carried explorer Ernest Shackleton's ill-fated expedition to Antarctica. The name for the spots where Curiosity and Perseverance landed honor science fiction writers Ray Bradbury and Octavia E. Butler, respectively. The Insight team named a rock that had been jostled by the lander's retro rockets during touchdown. Rolling Stones Rock, after the band, and the Curiosity team named a Martian hill after their colleague Rafael Navarro Gonzalez, who died from COVID-19 complications. Earth on Mars. Despite occasional exceptions, The Curiosity and Perseverance missions stick to nicknames based on terrestrial locations. Before Curiosity landed in 2012, the rover's team created a geological map of the landing area. They started by drawing a grid, making squares or quadrants equivalent to about zero point 0.7 miles, 1.2 kilometers on each side. These quadrants would be themed around a site of geological significance on Earth. Then, as now, team members suggested ideas for themes based on sites where they have worked or that they have a personal connection to, and they informally discussed which would be the most interesting to include, keeping in mind that various names would be memorialized in future scientific papers. Once a theme is picked, hundreds of names fitting into that theme are compiled. That many are needed because the available names can dwindle quickly, given that Curiosity may stay in a quadrant for several months. For Curiosity's latest quadrant, the rovers team chose a theme named after Roraima, the northernmost state of Brazil, and for Mount Roraima, the highest peak in the Pesaraima mountains, located near the border of Venezuela, Brazil, and Guyana. This marked the first South American quadrant theme. The sulfate enriched region Curiosity is currently exploring with its flat topped hills and steep slopes remain them of the tabletop mountains in the Pacaraima range. For perseverance, scientists choose to go with national park themes. The rover is now exploring the Rocky Mountain quadrant and recently drilled into rocks at a location bearing the nickname of Rocky Mountain National Park's Powell Peak. Andrew Good Jet Propulsion Laboratory, Pasadena, Calif 818-393-2433. Andrew C. Good JPL.nasa.government. Karen Fox, Alana Johnson, NASA Headquarters, Washington, 301-386-6284 by 202-358-1501. Karen C. Fox, NASA.government. Alana.R. Johnson, NASA.government, 2023 to 082. Radio low smoke dust, atmosphere of Mars, no water, no soil, surface dust, air and details. No water, no soil, surface dust, air and details. Radio low smoke dust, atmosphere of Mars, no water, no soil, surface dust, air and details. No water, no soil, surface rusty, iron no details, many craters everywhere. Some dry, some breezy, dull. So there are four seasons: autumn, summer, winter, spring. So there are the four seasons: autumn, summer, winter, spring. Many craters everywhere, some dry, some crystals. So there are four seasons: autumn, summer, winter, spring. So there are four seasons: autumn, summer, winter, spring. Radio low, smoky dust, atmosphere of Mars. No water, no soil, surface dusty and details. No water, no soil, surface dusty and details. Radial smoky dust, atmosphere of Mars. No water, no soil, surface dusty and dust details. No water, no soil, surface dusty and details. Crater JJ Rogel, our identity. Perseverance, curiosity, where it took the help of landing. Perseverance, curiosity, who took the help of landing. Crater JJ Rogel, our identity. Perseverance, curiosity, who took the help of landing. Perseverance, curiosity, who took the help of landing. Radio low, smoke dust, atmosphere of Mars. No water, no soil, surface dusty air and details. No water, no soil, surface dusty air and details. Radial smoke dust, atmosphere of Mars. No water, no soil, surface dusty air and details. No water, no soil, surface dusty air and details. The sky of Mars is very mysterious. Just like when we look at the sky from our earth, the day appears pale blue or the night appears completely blue. There is no existence of blue color in the sky of Mars, whether it is day or night. The sky of Mars appears orange, reddish, yellow, even from the outside, and from the inside also it appears orange, reddish, yellow. When we look at the sky from the surface of the earth, whether it is day or night, it always appears blue. But why is the sky of red, yellow, orange color from the surface of Mars? The sky of Mars appears red, yellow or orange because of the dust in its atmosphere, which is made up of iron oxide or rust particles, dust particles. The dust particles in Mars atmosphere are the right size to allow blue light to penetrate the atmosphere more easily than other colors scattered light. When blue light scatters of the dust, it stays closer to the sun than other colors. The remaining light scatters throughout the sky, making it appear yellow or orange, rusty color. The dust particles absorb blue light and scatter red light, giving the sky a rusty color. Mars surface is also reddish in color because of the iron oxide in its soil. However, up close, Mars actually has many different colors, including butterscotch, golden, brown, tan, and even greenish. The surface of Mars has an orange reddish color because its soil has iron oxide or rust particles in it. The sky on Mars often appears pink or light orange because the dust in the soil is blown into Mars' thin atmosphere by winds on Mars. Student video: Mars in a minute. Is Mars really red? NASA https www.jpl.nasa.government edu learn Mars in a minute. When you see Mars in the night sky, it definitely has a reddish tint to it. So in fact there are a lot of different colors on what we call the red planet. What do sunrises and sunsets look like on Mars? NASA science.government, HTTPS science.nasa.government, solar system, planets. Why is the sky of red, yellow, orange color from the surface of Mars? From science.nasa.government, 1 May 2019. What do sunrises and sunsets look like on Mars? NASA's Viking 1 lander first showed humans what a sunset looked like on Mars. The image above shows the Thrice Planetia region of Mars about 15 minutes before sunset on August 21, 1976. The low sun angle, bright light, topographic features. A depression is visible near the center of the picture, just above the lander's leg support structure, which was not evident in previous pictures taken at higher sun angles. Just beyond the depression are large rocks about 1 foot 30 centimeters across. The diffuse shadows are due to the sunlight that has been scattered by the dusty Martian atmosphere as a result of the long path length from the setting sun toward the horizon. Several bright patches of bare bedrock are revealed. Since the Viking 1 mission, NASA has launched several robotic missions to the red planet. They have sent back a variety of views of Martian sunrises and sunsets. Because Mars is further from the sun than Earth, the sun appears only about 2/3 the size we see when we watch sunsets here on Earth. Some images have been color corrected to show what human explorers might one day see while relaxing after a hard day's work on Mars. Here are some of those images. Perseverance rover sunset. This sunset on Mars was captured by NASA's Perseverance Mars rover using its Mastcam Z camera system on November 9, 2021. The 257th Martian day or sol of the mission. Martian sunsets typically stand out for their distinctive blue color. Fine dust in the atmosphere permits blue light to penetrate the atmosphere more efficiently than colors with longer wavelengths. But this sunset looks different. Less dust in the atmosphere resulted in a more muted color than average. The color has been calibrated and white balance to remove camera artifacts. Curiosity rover sunrays. NASA's Curiosity rover's Mars rover captured these sun rays shining through clouds at sunset on February 2, 2023. The 3730th Martian day or sol of the mission. It was the first time then that sun rays, also known as crepuscular rays, have been viewed so clearly on Mars. Crepuscular is taken from the Latin word for twilight, as these rays appear near sunset or sunrise. Insight lander sunrise. NASA's Insight lander used its instrument deployment camera IDC on the spacecraft robotic arm to image the sunrise on Mars on April 24, 2019. The 145th Martian day or sol of the mission. This image was taken around 5:30 a.m. Mars local time. Spirit Mars rover sunset. NASA's Mars exploration rover Spirit captured this stunning view as the sun sank below the rim of Drusiv crater on Mars on May 19, 2005. This panoramic camera PanCam mosaic was taken around 6-7 in the evening of the rover's 489th Martian day or sol. Spirit was commanded to stay awake briefly after sending that sol's data to the Mars Odyssey orbiter just before sunset. In the image, the bluish glow in the sky above the sun would be visible to us if we were there, but an artifact to the PanCam's infrared imaging capabilities is that with this filter combination, the redness of the sky further from the sunset is exaggerated compared to the daytime colors of the Martian sky. Viking 2 sunrise. NASA's Viking 2 lander captured this view of a Martian sunrise on June 14, 1970 at the spacecraft Utopia Planitia landing site. The data used to create this was acquired just as the sun peaked over the horizon on the lander 6:31 sol Martian solar day. Pictures taken at dawn or dusk are quite dark except where the sky is brightened above the sun's position. The glow in the sky results as light from the sun is scattered and preferentially absorbed by tiny particles of dust and ice in the atmosphere. Why is Mars red? Why are some images blue? Mars is known as the red planet because of iron oxide like rust in its soil. The planet's distinctive reddish hue is visible from Earth even without the aid of a telescope. The ancient Romans named it for their god of war Ares in Greek mythology. So, what's with the blue twilight? Just as colors are made more dramatic in sunsets on Earth, Martian sunsets would appear bluish to human observers watching from the red planet. Fine dust makes the blue near the sun's part of the sky much more prominent, while normal daylight makes the red planet's familiar rusty dust color more prominent. The colors come from the fact that the very fine dust is the right size so that blue light penetrates the atmosphere slightly more effectively, efficiently, said Mark Lemon of Texas A&M University College Station, a science team member of the Curiosity rover mission. When the blue light scatters of the dust, it stays closer to the direction of the sun than light of other colors does. The rest of the sky is yellow to orange, as yellow and the red light scatter all over the sky instead of being absorbed or staying close to the sun. Science behind the scenery. These images are more than just beauty shots. Martian sunset and twilight images help scientists determine how high into the atmosphere the Martian dust extends and allow them to look for dust or ice clouds. Other images have shown that the twilight glow remains visible but increasingly fainter for up to 2 hours before sunrise or after sunset. The long Martian twilight compared to Earth is caused by sunlight scattered around to the night side of the planet by abundant high altitude dust. Similar long twilights or extra colorful sunrises and sunsets sometimes occur on Earth when teeny dust grains that are erupted from powerful volcanoes scatter light high in the atmosphere. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. There was so much meteorite rain, yet Phobos and Deimos are intact. Air has disappeared from the surface, yet Mars is not in shock. Air has disappeared from the surface, yet Mars is not in shock. There was so much meteorite rain, yet Phobos and Deimos are intact. Air has disappeared from the surface, yet Mars is not in shock. Air has disappeared from the surface, yet Mars is not in shock. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Maybe even water has migrated from the surface to space. Gravitational force still a miracle. Our population saw the world in our dreams. Gravitational force is still a miracle. Our population saw the world in our dreams. Maybe even water has migrated from the surface to space. Gravitational force is still a miracle. Our population saw the world in our dreams. Gravitational force is still a miracle. Our population saw the world in our dreams. Fourth planet from the sun, news up with the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the sun, news up with the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Is the outer atmosphere of Mars filled with rust and iron powder? Yes, the outer atmosphere of Mars contains iron dust and rust, which is what gives Mars its distant red color. Iron dust. The dust on Mars is made of oxidized iron, which comes from the iron in the planet's rocks, regolith, and dust. Giant dust devils can kick up this dust into the atmosphere. Rust. Thus, iron in Mars rocks and soil has oxidized or rusted, giving the planet its red color. Mars has more than twice as much iron oxide in its upper layers than Earth. Atmosphere. The atmosphere of Mars is made up of carbon dioxide, nitrogen, argon, and trace amounts of other gases. Dust is a permanent part of the atmosphere, with more dust in the fall and winter and less in the spring and summer. Dust storms. Mars has the largest dust storms in the solar system, which can cover the entire planet and last for months. These storms usually happen in the spring and summer. Mars' atmosphere is over 100 times thinner than Earth's and is primarily composed of carbon dioxide, nitrogen, and argon gases. Oxidized dust particles kicked up from the Martian surface fill the atmosphere, turning Mars skies a rusty tan color, according to NASA, 17 September 2023. Mars, the red planet, facts and information, National Geographic, HTTPS, www.nationalgeographic.com, article Mars 1, 4 October 2016. Planet Mars explained: the rusty world is full of mysteries, and some of the solar system's most extreme geology. Learn more about Earth's smaller, colder neighbor by Mikhail Gresko. 11-minute read. The red planet Mars, named for the Roman god of war, has long been an omen in the night sky, and in its own way, the planet's rusty red surface tells a story of destruction. Billions of years ago, the fourth planet from the Sun could have been mistaken for Earth's smaller twin, with liquid water on its surface and maybe even life. Now the world is a cold, barren desert with few signs of liquid water, but after decades of study using orbiters, landers and rovers, scientists have revealed Mars as a dynamic, wind-blown landscape that could just maybe harbor microbial life beneath its rusty surface even today. A tale of two hemispheres. About 4.5 billion years ago, Mars coalesced from the gaseous dusty disk that surrounded our young sun. Over time, the red planet's innards differentiated into a core, a mantle, and an outer crust that's an average of 40 miles thick. That Mars, which we know as the red planet, for its complete red cover, that red planet has become so familiar with us today because of NASA's wonderful exploration efforts and especially because of my lovely attraction and expansion efforts. NASA's Mars exploration, the world has a history. If fossils like Luca, the right effort will be made. If fossils like Luca, the right effort will be made. NASA's Mars exploration, the world has a history. If fossils like Luca, the right effort will be made. If fossils like Luca, the right effort will be made. Luca was an ancient creature on earth. Luca did not need to breathe. Iron metal Luca's survival. Alien life Luca's heaven. Iron metal Luca's survival. Alien life Luca's heaven. Luca was an ancient creature on earth. Luca did not need to breathe. Iron metal Luca's survival. Alien life Luca's heaven. Iron metal Luca's survival. Alien life Luca's heaven. NASA's Mars exploration, the world has a history. If fossils like Luca, the right effort will be made. If fossils like Luca, the right effort will be made. NASA's Mars exploration, the world has a history. If fossils like Luca, the right effort will be made. If fossils like Luca, the right effort will be made. Luca was pointed in Mars because rust is on the surface of iron. NASA search for the same clue, so the search of the robots is the same. NASA search for the same clue, so the search of the robots is the same. Luca was pointed in Mars because rust is on the surface of iron. NASA search for the same clue, so the search for the robots is the same. NASA search for the same clue, so the search of the robots is the same. NASA's Mars exploration, the world has a history. If fossils like Luca, the right effort will be made. If fossils like Luca, the right effort will be made. NASA's Mars exploration, the world has a history. If fossils like Luca, the right effort will be made. If fossils like Luca, the right effort will be made. When Mars is seen in the twinkling night sky, it looks very yellowish, and nowadays Mars looks very bright red because the way Mars is getting the radiation of the sun, The night side of Mars is also glowing with the heat of Jupiter. These days, Mars has become a new addition to NASA's historical discoveries. When NASA first laid eyes on Mars and especially the exploration of Spirit and other rovers, the surface of Mars was found to be the existence of our Earth's ancient star like Luca. Today we are considering Mars as an alternative to our world. Perhaps we will make Mars our survival place tomorrow. But thanks to NASA, we still feel that Mars once had biological senses. Did the rusty iron surface of Mars give NASA the sense of Earth's ancient life, Luca? Signs of ancient life on Mars. Here's what we see in this NASA science.government. HTTPS science.nasa.government. Resource Science of Ancient Life 25 July 24. Science of Ancient Life on Mars. Here's what we see in this intriguing rock shorts. NASA's Perseverance rover has made very compelling observations in a Martian rock that with further study could prove that life was present on Mars in the distant past. But how can we determine that from a rock, and what do we need to do to confirm it? Morgan Fable, a scientist on the Perseverance team, takes a closer look. For details on each of the samples, see science.nasa.government. Mission Mars 2020 Perseverance Mars rock sample. Compelling evidence found for ancient life on Mars. NASA.government. HTTPS solarsystem.nasa.government. News compelling evidence 13 December 2000. And Iowa State University professor is part of a research team that has found compelling evidence that Mars once supported primitive life. NASA's Perseverance rover deciphers ancient history of NASA.government. HTTPS www.nasa.government. Mars 2020 Perseverance NASA 12 December 2023. NASA's Perseverance rover deciphers ancient history of Martian lake. How at 1000 days on Mars, the mission has traversed an ancient river and lake system, collecting valuable samples along the way, marking its 1000 Martian day on the red planet. NASA's Perseverance rover recently completed its exploration of the ancient river delta that holds evidence of a lake that filled Jezero crater billion of years ago. The six-wheeled scientist has to date collected a total of 23 samples, revealing the geologic history of this region of Mars in the process. One sample called Lefroy Bay contains a large quantity of the fine-grained silica, a material known to preserve ancient fossils on Earth. Another Otis Peak holds a significant amount of phosphate, which is often associated with life as we know it. Both of these samples are also rich in carbonate, which can preserve a record of the environmental conditions from when the rock was formed. The discoveries were shared Tuesday, December 12th, at the American Geophysical Union fall meeting in San Francisco. We picked Jezero crater as a landing site because orbital imagery showed a delta. Clear evidence that a large lake once filled the crater. A lake is potentially habitable environment, and delta rocks are a great environment for entombing signs of ancient life as fossils in the geologic record, said Perseverance's project scientist Ken Fairley of Caltech. After thorough exploration, we have pieced together the crater's geologic history, charting its lake and river face from beginning to end. Jezero formed from an ancestral impact almost 4 billion years ago. After Perseverance landed in February 2021, the mission team discovered the crater floor is made of igneous rock formed from magma underground on or from volcanic activity at the surface. They have since found sandstone and mudstone, signaling the arrival of the first river in the crater hundreds of millions of years later. Above these rocks are salt-rich mudstones, signals the presence of a shallow lake experiencing evaporation. The team thinks the lake eventually grew as wide as 22 miles, 35 kilometers in diameter, and as deep as 100 feet, 30 meters. Later, first flowing water carried in boulders from outside Jezero, distributing them at top of the delta and elsewhere in the crater. We are able to see a broad outline of these chapters in Jezero's history in orbital images, but it required getting up close with Perseverance to really understand the timeline in detail, said Libby Leibs. Libby Ives, a postdoctoral fellow at NASA's Jet Propulsion Laboratory in Southern California, which manages the mission. NASA's Mars exploration, the world has a history. If fossils like Luca, the right effort will be made. If fossils like Luca, the right effort will be made. NASA's Mars exploration, the world has a history. If fossils like Luca, the right effort will be made. If fossils like Luca, the right effort will be made. Luca was an ancient creature on earth. Luca did not need to breathe. Iron metal, Luca's survival. Alien life, Luca's heaven. Iron metal, Luca's survival. Alien life in Luca's heaven. Luca was an ancient creature on the earth. Luca did not need to breathe. Iron metal Luca's survival. Alien life in Luca's heaven. Iron metal Luca's survival. Alien life in Luca's heaven. NASA's Mars exploration. The world has a history. If fossils like Luca, the right effort will be made. If fossils like Luca, the right effort will be made. NASA's Mars exploration. The world has a history. If fossils like Luca, the right effort will be made. If fossils like Luca, the right effort will be made. Luca was pointed in Mars because rust is on the surface of iron. NASA searched for the same clue, so the search of the rovers is the same. NASA searched for the same clue, so the search of the rovers is the same. Luca was pointed in Mars because rust is on the surface of iron. NASA search for the same clue, so the search for the rovers is the same. NASA search for the same clue, so the search of the rovers is the same. NASA's Mars exploration, the world has a history. If fossils like Luca, the right effort will be made. If fossils like Luca, the right effort will be made. NASA's Mars exploration, the world has a history. If fossils like Luca, the right effort will be made. If fossils like Luca, the right effort will be made. NASA's Mars exploration. I examined the dust that was sticking to my feet. Was there any living organism in these dust particles before? NASA's Mars exploration was a search for alien life like Luca really going on in this red dusty rock? Where alien life like Luca microorganisms? The last universal common ancestor, Luca, a single-celled microbe that lived about 4 billion years ago, is thought to have had a lifestyle that was somewhat alien. Some evidence suggests that Luca lived in hydrothermal vents deep underground where it was surrounded by iron and sulfur. There are some other things to know about Luca. Biochemical similarity. The existence of Luca is widely accepted by biochemical chemists because of the detailed biochemical similarity of all current life. Ancestral organisms. Luca is the hypothesized common ancestor of all modern cellular life, including humans, bacteria, and redwood trees. Early immune system. Some research suggests that Luca was a prokaryote grade anaerobic acetogen with an early immune system. Ecological system. Although Luca is sometimes thought to have lived in isolation, some research suggests that it was part of an established ecological system. Around 4 billion years ago, there lived a microbe called Luca the last universal common ancestor. There is evidence that it could have lived a somewhat alien lifestyle, hidden away deep underground in iron sulfur rich hydrothermal vents. 30 March 2017. Looking for Luca, the last universal common ancestor. News NASA astrobiology.government. https astrobiology.nasa.government. News looking for Luca. Aerobic and autotrophic, it didn't breathe air and made its own food from the dark metal rich environment around it. Its metabolism depended upon hydrogen, carbon dioxide and nitrogen, turning them into compounds such as ammonia. Most remarkable of all, this little microbe was the beginning of a long lineage that encapsulates all life on earth. If we trace the tree of life far enough back in time, we come to find that we are all related to Luca. If the war cry for our exploration of Mars is follow the water, then in the search for Luca, it's follow the genes. The study of the genetic tree of life, which reveals the genetic relationship and evolutionary history of organisms, is called phylogenetics. Over the last 20 years, our technological ability to fully sequence genomes and build up vast genetic libraries has enabled phylogenetics to truly come of age and has taught us some profound lessons about life's early history. For a long time, it was thought that the tree of life formed three main branches or domains, with Luca at the base: eukarya, bacteria, and archaea. The latter two, the prokaryotes, share similarities in being unicellular and lack a nucleus, and are differentiated from one another by subtle chemical and metabolic differences. Eukarya, on the other hand, are the complex multicellular life forms comprised of membrane encased cells, each incorporating a nucleus containing the genetic code as well as the mitochondria organelles powering the cell's metabolism. The eukarya are considered so radically different from the other two bacteria branches as to necessarily occupy its own domain. However, a new picture has emerged that places eukarya as an offshoot of bacteria and archaea. This two-domain tree was first hypothesized by evolutionary biologist Jim Lake at UCLA in 1984, but only got a foothold in the last decade, in particular due to the work of evolutionary molecular biologist Martin Emble and his lab at the University of Newcastle, UK, as well as evolutionary biologist William Martin at the Heinrich Heine University in Dusseldorf, Germany. Bill Martin and six of his Dusseldorf colleagues, Madeline Weiss, Philippa Sousa, Natalia Manjavec, Sinjay Nekrichen, Mayo Roedger, and Sijulal Nelson Sethi published a 2016 paper in the journal Nature Microbiology describing this new perspective on LUCA and the two-domain tree with phylogenetics. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. There was so much meteorite rain, yet Phobos and Deimos are intact. Air has disappeared from the surface, yet Mars is not in shock. Air has disappeared from the surface, yet Mars is not in shock. There was so much meteorite rain, yet Phobos and Deimos are intact. Air has disappeared from the surface, yet Mars is not in shock. Air has disappeared from the surface, yet Mars is not in shock. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Maybe even water has migrated from the surface to space. Gravitational force still a miracle. Our population saw the world in our dreams. Gravitational force is still a miracle. Our population saw the world in our dreams. Maybe even water has migrated from the surface to space. Gravitational force is still a miracle. Our population saw the world in our dreams. Gravitational force is still a miracle. Our population saw the world in our dreams. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. Fourth planet from the sun, news of the red planet. No air, no water, yet the gravitational force is tremendous. No air, no water, yet the gravitational force is tremendous. If organisms without respiratory systems are our ancestors, why then do organisms without respiratory systems not exist today? Can alien organisms like Luca still exist today? The last universal common ancestor Luca is a typically hypothetical cell that is believed to have lived between 3.6 and 4.3 billion years ago, and from which all life evolved. There is no fossil evidence of Luca, but the biochemical similarities of all current life strongly support its existence. Some believe that Luca may have lived in hydrothermal vents deep underground and that it may have had a somewhat alien lifestyle. However, others believe that there may not be a single Luca but rather an indefinable evolutionary starting point for life. While no fossil evidence of the Luca exists, the detailed biochemical similarity of all current life divided into the three domains makes its existence widely accepted by biochemists. Its characteristics can be inferred from shared feature of a modern genome. Looking for Luca, the last universal common ancestor, NASA astrobiology.government, HTTPS astrobiology nasa.government. News looking for Luca, 30 March 2017. Ancient genes. Previous studies of Luca looked for common universal genes that are found in all genomes based on the assumption that all life has these genes. Then these genes must have come from Luca. This approach has identified about 30 genes that belong to Luca, but they are not enough to tell us how or where it lies. Another tactic involves searching for genes that are present in at least one member of each of the two prokaryote domains, archaea and bacteria. This method has identified 11,000 common genes and could potentially have belonged to Luca, but it seems far fetched that they all did. With so many genes, Luca would have been able to do more than any modern cell can. Bill Martin and his team realized that a phenomenon known as lateral gene transfer (LGT) was muddying the waters by being responsible for the presence of most of these 11,000 genes. LGT involves the transfer of genes between species and even across domains via a variety of processes such as the spreading of viruses or homologous recombination that can take place when a cell is placed under some kind of stress. A growing bacteria or archaea can take in genes from the environment about them by recombining new genes into their DNA. Start 10. Often this newly adopted DNA is closely related to the DNA already there, but sometimes the new DNA can originate from a more distant relation. Over the course of 4 billion years, genes can more move around quite a bit, overwriting much of Luca's original genetic signal. Genes found in both archaea and bacteria could have been shared through LGT and hence would not necessarily have origin in Luca. Knowing this, Martin's team searched for ancient genes that have exceptionally long lineage but do not seem to have been shared around by LGT on the assumption that these ancient genes should therefore come from Luca. They laid our conditions for a gene to be considered as originating in Luca. To make the cut, the ancient gene could not have been moved around by LGT and it had to be present in at least two groups of archaea and two groups of bacteria. While we were going through the data, we had goosebumps because it was all pointing in one very specific direction, says Martin. Once they had finished their analysis, Bill Martin's team was left with just 355 genes from the original 11,000 and they argue that these 355 definitely belong to Luca and can tell us something about how Luca lived. Such a small number of genes, of course, would not support life as we know it, and critics immediately latched onto his apparent gene shortage, pointing out that essential components capable of nucleotide and amino acid biosynthetics. For example, we are missing, we didn't even have a complete ribosome, admits Martin. However, their methodology required that they omit all genes that have undergone LTG, so had a ribosomal protein undergone LGT, it would not be included in the list of Luca's genes. They also speculated that Luca could have gotten by using molecules in the environment to fill the functions of lacking genes. For example, molecules that can synthesize amino acids. After all, says Martin, biochemistry at this early stage in life's evolution was still primitive and all the theories about the origin of life and the first cells incorporate chemical synthesis from their environment. What those 355 genes do tell us is that Luca lived in hydrothermal vents. The Dusseldorf team's analysis indicates that Luca used molecular hydrogen as an energy source. Serpentization within hydrothermal vents can produce copious amounts of molecular hydrogen, plus Luca contained a gene for marking an enzyme called reverse gyres, which is found today in extreme fields existing in high temperature environments including hydrothermal vents. Friends, Mars is the twin sister of our Earth, my favorite planet. I have written articles about Mars many times. This time I have written about Mars in the solar system project. You decide whether this article of mine will give the right direction to the coming generation or not. Till then, allow me to start about Jupiter.